So up until this point in this chapter, we've been talking a lot about what are called inequalities. So less than, greater than, less than or equal to, or greater than or equal to. Today we're going to sort of change pace. Today we are going to be talking about something called absolute value equations. And the reason I'm teaching you this is so that I can teach you eventually about absolute value inequalities. So we're going to start today with equations. Just like we started this year by solving equations and then we learned how to solve inequalities, we're going to start with absolute value equations, which is a special type of equation, and then eventually we're going to learn how to solve absolute value inequalities. So let's start with what is absolute value. The absolute value of a number is the distance between the number and 0 on a number line. Now, to represent that we want to find that distance, we put down the number, let's say like A, and we put two vertical lines around the outside of it. We call those absolute value bars. So these two vertical lines mean absolute value. All right, so on a number line, what exactly am I talking about? Well, let's do two problems. First, let's find the absolute value of -4. What this means is how far away is the number -4 from the 0. So if I find the -4 on the number line, and then I count how many spaces are between the -4 and the 0, I get 4 spaces. Now, if I do a second problem here, and I do the absolute value of +4, on the number line, if I find the +4, and then I count how many spaces are between the 0 and the +4, I also get 4. So here's what we know. We know that the absolute value of a number is always a positive number. Now this is really important, that the answer here is always positive. The other thing that's really important is that no matter what the answer is, like if the answer was 4, the number that was inside of the absolute value could have been a negative number or a positive number. They both give you the same answer. Now, why are we talking about this? Well, let's practice evaluating some problems. If I say find the absolute value of -2, your answer would be 2, because an absolute value means make it positive. Now, number 2, what's the absolute value of +3? Would just be +3, because an absolute value means make it positive. And since this number was already positive, it would just stay the same. Now there's another rule about absolute values. We know that when there's parentheses in a problem, we have to do whatever's inside of the parentheses first and then simplify afterwards. Parentheses is always first in order of operations. So absolute value works the same way as parentheses. We need to simplify whatever is inside of the absolute value first. So in this problem, I would do 2 minus 3, which means I would get -1. Now the absolute value is still there because I haven't done that part yet. I haven't taken my answer and made it positive. Now the absolute value of -1 would be +1, and that would be my answer. Let's try one more like that. Number 4. I would simplify what's inside of there. So I would have the absolute value of -9, and the absolute value of -9 would be +9. Now let's try a couple problems where we need to substitute. So we're going to take numbers, plug them in, then simplify. It says the absolute value of x minus 2 when x is 3. So what I'm going to do is I'm going to take the 3 and I'm going to plug it in inside of the absolute value. So I'm going to have the absolute value of 3 minus 2. Now the 3 minus 2 simplifies to 1, and the absolute value of 1 would just be 1. For number 6, we would take the x and the y and plug them both in. So we have the absolute value of negative 4 minus, when you plug in the y, you plug in 5. Now in this problem, the absolute value is only around the negative 4. So the answer would be positive 4, and then I just drop down the minus 5. 4 minus 5 would be negative 1, and that would be my final answer. Now that we know a little bit about absolute values, let's see if we can solve some equations that have absolute values in them. So an absolute value equation is any equation involving an absolute value symbol. Every absolute value equation has two answers, and here's why. If I tell you that the absolute value of my mystery number is 4, then that means find me a number that is 4 spaces away from 0. Now if we go up here to our first example, there are actually two different numbers that are 4 spaces away from 0, the negative 4 and the positive 4. If I have a negative 4 and I take the absolute value, I get positive 4. If I have a positive 4 and I take the absolute value, I get positive 4. So if I'm looking for numbers that will give me positive 4, I would say positive 4 will, but so will negative 4. So there are two answers here to this problem. How can we use that to solve more problems? This idea that there are two answers, a positive and a negative of the same number. Well, if I say the absolute value of x is 7, you would say then x must have been 7 or x must have been negative 7. That's pretty easy. But what if I say that the absolute value of a number minus 7 should equal 9? Now this one's not so easy. You might think to yourself, I can solve this equation, I'm just going to add the 7. But remember how absolute value was kind of like parentheses? You can't just get out the 7 without getting rid of the absolute value. Think about the absolute value as being like in jail. It can't escape. You cannot just add the 7 on both sides to figure out this answer. Instead, what you have to do is what I call make two branches. You're going to make two separate problems here. The first problem is going to be a copycat of the original. R minus 7 equals 9. It's just that you take away the absolute value symbol now. So this is a copycat without the absolute value symbol. Now the second equation that you're going to write is going to be a little bit different. You're going to copy the left side, but instead of equaling positive 9, you're going to equal negative 9. So for this one, you change the sign of the number, you made it negative, and you take away, so it's without the absolute value symbol. Now that's what you're going to do every time. You're always going to copy the original, and then you're always going to rewrite it with a negative number. These equations do not have absolute values in them, so these are equations we can solve. We would add 7 on both sides, and we would get r equals 16 is my first answer. And then we would add 7 on both sides, and we would get r equals negative 2 is my second answer. Now, one common mistake that I usually see here is that students think we should get the same number for both of our answers, just with different signs, and that is only the case once in a while. This one was a 7 and a negative 7, but the correct answers for this problem are not the same numbers. One of them is a 16, one of them is a negative 2. So do not think that you're just going to have the same number with two different signs. Let's try a few more examples. So for number 3, we would start by rewriting this as 2 separate problems. So first, you rewrite it. The first problem will be a copycat of the original, 3x minus 4 equals 5. The second problem will be a copycat of the original, but with a negative 5. Then, you would just solve 2 separate problems. So, let's solve the first one. We would add 4 on both sides and get 3x equals 9. Then we would divide by 3 on both sides and get x equals 3. In the second problem, we would add 4 on both sides and we would get 3x equals negative 1. Then we would divide by 3, so x equals negative 1/3. And those would be my 2 answers. Now that's a pretty straightforward example, but let's look at one that's a little bit tougher. In this problem, you'll notice that we have the absolute value, but we also have some numbers that are outside of the absolute value. Like, see how this 3 is on the outside and the negative 5 is on the outside? Before we can rewrite it, we need our first step to be isolate the absolute value. In other words, we want the absolute value to be by itself on the left side. So let's see if we can do that. In order to get the absolute value by itself, you're going to add 5. You get 3 times the absolute value of 2x minus 7 equals 9. Now you cannot distribute the 3. Remember, those numbers are in jail. You can't touch them till you can break them out by making 2 separate equations. So you would divide by 3 on both sides, and you would get the absolute value of 2x minus 7 equals 3. After you isolate the absolute value, step 2 should be to rewrite 2 equations. Now the absolute value was still in the problem the whole time until we got to here, and from here it can go away. One we keep the same, one we change to a negative 3. You'll notice that there are no more absolute value symbols anymore, because when you rewrite it, you break it up, you take away the jail. So, we add 7 on both sides. We get 2x equals 10. Then we divide by 2, so we get x equals 5. That's our first answer. And then we add 7 on both sides. We get 2x equals 4. We divide by 2 on both sides. We get x equals 2. All right, let's try one more problem where we have to isolate the absolute value first. So let's look at number 5. You'll notice there's a number on the outside of the absolute value. So the first thing I'm going to do is add the 4 to isolate the absolute value. Absolute value of x plus 3 equals 3. Now, there's no more numbers on the outside, so this is when I split it up and I make 2 separate problems. X plus 3 equals 3, and x plus 3 equals negative 3. Now what I'm going to do is solve these separately. You'll notice the absolute value symbols are gone because once you break it out, it broke out of jail, you don't have to write them anymore, and you get 2 separate answers. We will save number 6 in case we need another example to do in class tomorrow. Thank you so much for being patient and watching, and I will see you to practice this tomorrow.